All right, first let's talk about this warm-up question. If you listed all the numbers between 3 and 6, you might have said, okay, well, 4 and 5. But actually, no, there's a lot of numbers between 3 and 6, right? There's 3.1, there's pi, there's 4.17523. There's actually like an infinite amount of numbers between 3 and 6 because I could just keep going with this decimal and it becomes a different number. So you actually can't list all the numbers between 3 and 6. It's impossible. Okay, so this gets us into our conversation about discrete versus continuous domain and range. So what you learned yesterday is about what's called discrete domain and range. Okay, so in real life, these are things that are counted. Okay, you're going to see what I mean in a second. So for example, like cars, books, people. If I say like, oh, how many cars are in the lot? You would just be like, oh, let me count. 1, 2, 3. Oh, how many books are in that stack? Let me just count, right? Oh, how many people are in here? You would just count. Okay, now what we're going to talk about today is something called continuous domain and range, and this is for stuff that's measured. So for example, if I said, well, like how much water do you have? You wouldn't count water, right? You don't count water, you would measure it. You'd say, oh, I have a gallon, right? Or if I asked about sand, right? You wouldn't count, oh, I have, 5 billion grains of sand. You would just measure how much sand you have. So there's certain things that are measured. And then like this is also true for, there's things, for example, at the store that are sold by the pound, right? Like if I buy peaches, I pay per pound. So in that case, like those things aren't, we don't say, oh, I bought 5 peaches. Say I bought 3 pounds of peaches. Okay, so like per pound kind of purchases would be something that's continuous. So the graphs that we've seen so far, so like what you saw yesterday for domain and range, the graph looked like this. And it was discrete points. It was individual points. Whereas with continuous domain and range, it's going to look more like this, where it's a continuous line and it includes all the points. Look, like this x value, it includes all the x values up to 4, all of them, including the decimals, including pi, including everything, all the numbers up to 4. Okay, so what happens is in this discrete one, the x and y values were just individual numbers. They were like particular numbers. Right? And remember the domain and range, they look like this. Like it was like 3, 5, 7, right? Maybe your range was like -2, 0, 5, right? Like this is what the domain and range look like. Now, over here, we're not saying, oh, the x value could be 1, it could be 2, it could be 3. We're saying, oh man, it could be anything in this range of numbers. Any number, it could be a decimal, it could be anything. So here the x and y values are a range of numbers. And what the domain and range look like is the domain would look like this. Like let's say for this circle, the domain is the x values all the way from here to here. So that would be from -4, right? X can be -4, or it can be greater than -4, or it can be all the way to 4 or less than 4. Okay, so that would be what a domain looks like. And then let's say for a range, like let's do the other graph, right? Like the range here, the bottom is here at -3 and the top is here at 3. So like the range of that graph would look like, oh, right, sorry, bottom is here at 3, a -3, and the top is here at +3. So the range would look like this. Okay, so this is what the domain and range looked like yesterday, and this is what domain and range will look like today. Okay, right now you're going to take a moment and you're going to decide, is this discrete or continuous? Okay, these two real life examples and these two graphs.